Hi, this is a video to explain the work done by a spring. It's extremely important to master this one. So you can see a box that's bobbing up and down on a spring, and if you look at the side view, there is a mean position where the spring is most comfortable, which is x equal to 0, and some external force, let's say our hand, was required to initially compress the box down, and then it keeps bobbing up and down. So the external force is provided, and then the spring creates a restoring force, and that F is equal to minus kx shows that as you compress the spring more and more, or as you extend the spring more and more, a higher and higher force is needed. What I'm trying to say is that F changes with x. It's not the same case as a block being moved on a plane surface. So it becomes a graph. So F versus x is a graph, and the area under the curve creates a third person, and the third person is the work done. Therefore, let's get down to integration. Integration is nothing but the small rectangles under the curve, which are all added up, and each of the rectangle is nothing but the y-axis f into that small dx on the x-axis. So integration of f into dx for a displacement from any 2 points on the x-axis, from x1 to x2 say, then substitute minus kx into that equation. Minus k comes out of the integral because spring constant is a constant, and integration of x dx, as you know, is x squared by 2. So if you take the by 2 outside the brackets, then you get an equation for work which is minus k half into x2 squared minus x1 squared. Incidentally, if a spring is moving from max position to its min position and coming back to the mean position, the net displacement of that spring is 0 and the work done is 0. Just to remember that. Let's look at a small numerical which will help us to clarify this concept. So somebody compresses a spring using a box on top of it by 10 millimeters. Spring constant is given, and our job is to find the work done by the spring on the box. So we use the same concept and plug in the equation. Here the spring was initially in its rest position, so x1 is 0. It was compressed to x2 equal to 10 millimeters. Convert everything into 1 unit and you will get work done is minus 0.05 joules. I hope this presentation was useful for you. Thank you and bye-bye.